So this is a little bit of a tricky problem in that it gives us a lot of different values. But actually, when it comes down to it, it's just basic vector addition. So let's look at this. It says that a boat is traveling upstream at 14 kilometers an hour with respect to the river. So the boat in flat water would be going 14 kilometers an hour. The river is flowing downstream, because that's what rivers do. They flow downstream at 6 kilometers an hour with respect to the ground. So a person standing on the shore next to this river. All right, it says a man runs across the boat from one side to the other at 6 kilometers an hour with respect to the boat. We want to know what is the speed of the man with respect to the ground. So let's draw a picture first. I know that I have a river. River is going in the downward direction and it has a value of 6 kilometers per hour. I have my boat going upstream at a velocity of 14 kilometers per hour. And I have a person going across. Velocity of the man is equal to 6 kilometers per hour. All right. Now when I go through and solve this problem, I'm actually going to just write down each of these values given a coordinate system. So now I have a picture. I've labeled my picture. I'm going to draw my coordinate system to be x, positive x, and positive y. So my velocity of the river, my velocity of the boat, and my velocity of the man. I'm going to draw these things in full vector. These should be full vectors. All right, so the velocity of the river I said was 6 kilometers an hour, but it's 0 in the x direction and minus 6 in the y direction. We're going to assume kilometers per hour for the whole problem. My velocity of the boat, 14 kilometers in the vertical direction, so that'd be plus 14 kilometers per hour in the y direction, goes along with my y arrow, and 0 in the x direction. And last but not least, the man goes across the boat at 6 kilometers an hour in the x direction, from left to right, and does not go forward with respect to the boat. The boat's going forward in the river's pulling it back, but as far as the boat is concerned, or as far as the person's concerned, in the boat, they're only going straight across. So the river is with respect to the shore, the boat is with respect to the river, and the man is with respect to the boat. So logically, we can go through this and just add up these vectors. So the speed of the man with respect to the shore is equal to 6 in the x direction plus 8 in the y direction. So that means this person is going in 6 over and 8 up. So it's going in a kind of in an up and to the right sort of mode. The magnitude of this is just the square of the square root of the squares. So 6 squared is 36, 8 squared is 64, 36 plus 64 is 100, square root of 100 gives me 10 kilometers an hour. So the man with respect to the shore is going at 10 kilometers an hour. It's not a straight add up all of our numbers, not the case where we just add up and subtract up the numbers, but we have to do the full vector addition for these numbers. And we have to check to make sure that the velocities they gave us are appropriate to add. So knowing that the man is with respect to the boat allows us to figure out how to add these two. The boat is with respect to the river, so we can add those two together.